We have three special cases of binomials that can be factored. One is called the difference of squares. Notice we have a squared minus b squared. One is the sum of cubes, which is a cubed plus b cubed. And the other is the difference of cubes, a cubed minus b cubed. These three binomials, these three types of binomials have a special pattern that can be followed. If you remember the pattern, then you should be able to factor binomials of these types. Let's start with the difference of squares. The pattern that will follow for the difference of squares is that the difference can be broken up into a sum and a difference, a plus b times a minus b. As an example, x squared minus 16 can be broken up into x plus 4 and x minus 4. The square root of the x squared, x and x, the square root of 16, 4 and 4, plus and minus as our signs. If we multiply this out to check, we have x times x, which is x squared. We have negative 4x plus 4x, which cancels the x's, and 4 times negative 4, which is negative 16. The difference of squares can come from these two binomials in which we have the same terms and opposite signs so that the middle term cancels out. Another example, x squared minus 36. We have the difference of perfect squares, break down into the square roots with plus and minus sign, and we have the factored form. Now this will not work for the sum of squares because we will have the same sign. Since this is the last sign in our binomial, we'll have the same sign either both plus or both minus, and there's no way to cancel out that middle term. Let me give you a practice problem. X squared minus 81. Factor this binomial and then come back to check your answer. In factoring this, we should notice that we have a difference of perfect squares, so we can break up that binomial into two binomials, plus and a minus, breaking down x squared into x times x, and 81 into its perfect square, perfect square roots 9 and 9. X plus 9x minus 9. Try this problem. It'll be a little bit more involved. See if you can follow it all the way through. Pause the video. Come back to it after you solve the problem to check your answer. In this problem, it's a difference of perfect squares. The square root of x to the fourth is x squared. The square root of 16 is 4, plus and minus. As I said before, we cannot factor a sum of squares, but we can continue to factor any difference of squares. Here we have another difference of squares, x squared minus 4, plus and minus 2 and 2, and we've now factored x to the fourth minus 16 completely into these three binomials. Let's now look at the sum and the difference of cubes. The pattern to follow is very similar for the sum and the difference of cubes. In both cases, you'll be breaking the binomial into a binomial times a trinomial. The binomial will always include each of the cube roots with the same sign as the beginning. So a cubed plus b cubed, the binomial for that will be a plus b. A cubed minus b cubed, the binomial will be a minus b. The second factor in each case will be a trinomial, and the trinomial comes from these parts. If we take out the a, we're left with a squared as the first term. If we take out a b, we have a b squared for the last term, and that's true for both cases. The middle term will be made up of each of the cube roots, a and b, but the signs will be like this. There will be one negative sign in each factoring. So for the a cubed minus b cubed, since we already used up the one negative sign, these two have to be plus. For the sum of cubes, we need a negative sign somewhere in here. It'll be in front of the middle term. If you multiply these factors together, the a plus b times a squared minus ab plus b squared, you'll get a cubed plus b cubed. Same thing with the other factored form. You might want to try that on your own just to make sure. So let's look at how we factor this. Look at an example of this. X cubed minus 27. This is a difference of cubes in that we have an x cubed minus 3 cubed. So we can see we have a difference of perfect cubes. I use the parentheses to help me to pull out the a's and the b's for the factored form. Remember, because we have a difference of cubes, we're going to have a binomial times a trinomial. The sign of our original problem will be in the binomial, which means since we only have one negative sign throughout the whole pattern, we've already used it up. The other two signs will be positives. In the binomial, we have each of the cube roots of the original value of the original terms. In this case, when you look in the parentheses, we can just pull out the x and the 3. The first term in the trinomial will be the first term, that the value in parentheses squared, x squared, and the last term will be the value in parentheses at the end, cubed, squared, 3 squared. The middle term will come from the values in the parentheses, 3x. Simplifying a little more, here is the factored form for x cubed minus 27. Let's look at another example. 8x cubed plus 125, I have a sum of perfect cubes. If I rewrite each of these terms as a quantity cubed, I would have 2x quantity cubed plus 5 cubed. I have a sum of cubes, which means I can break that into a binomial times a trinomial. My sign is plus in the original, so my binomial will have the plus sign. Then I just have to remember that the middle sign is negative in the trinomial, the last sign is positive. I can take out what I have in the parentheses for the binomial, 2x and 5. For the trinomial, I'll have 2x squared and 5 squared, with a middle term of 2x times 5, the a and the b. Simplifying, I'll have 4x squared when I square the 2x, minus 10x, plus 25. Once again, you can multiply the binomial times the trinomial to see if you end up with 8x cubed plus 125. Let me give you an example, or a practice problem. X cubed minus 8. Pause the video, work the problem, and come back to check your answer. We can see that we have a difference of cubes. We have x cubed minus 2 cubed. We can break it into a binomial times a trinomial. The binomial will have the same sign as the original. Since we already used up the one negative sign, the other two must be plus. In the binomial, I can take out each of the values that are in the parentheses. For the trinomial, the first term will be the first value in parentheses squared. The last term will be the last value in parentheses squared, 2 squared. And the middle term will be a combination of 2 times x. Simplify one step further, and we have the factored form of x cubed minus 8. One more practice problem. In this case, we don't have perfect cubes right away, but you may notice that you can factor out a monomial first. Go ahead and do that, carry through with the difference of cubes, and then come back to the video to check your answer. In this problem, we can divide both of the terms by 3 and x. And we're left with x to the 6th minus 8y cubed. We have perfect cubes, a difference of perfect cubes. We can show that a little bit better if we write this as x squared cubed minus 2y quantity cubed. We have a difference of cubes, which means we can break that difference of cubes into a binomial times a trinomial. My sign is negative in the binomial, so I can, or in the original problem, so I have a negative in the binomial and positives in the trinomial. I can take out, for the binomial, what's in parentheses, x squared and 2y. For the first term in the trinomial, I can take the x squared and square it, and the 2y and square it for the last term. And the middle term is a combination of the 2y and the x squared, 2x squared y. Simplify one step further. And I have the factored form of 3x to the 7th minus 24xy cubed. Notice I kept the 3x throughout the rest of the problem. So remember, for binomials, if we have the special cases of the difference of squares, the difference of cubes, or the sum of cubes, we can follow these patterns to factor them down. Remember also, always try to factor out a monomial first.